Hi, Nachinok. Hi, Da. I hope you're doing well. And in this video, I want to try and talk a little bit about the residential sector and to show how we can create the residential sector in Leap for Thailand. I have looked at your residential sector data. So let's try and I want to give you a couple of options for how we can put it into Leap, and then we can you can decide whether which one of these is the best option. So when we're creating a new branch, a new module, it's often easier to do it in a new Leap dataset and then to import it back into the main Leap Thailand dataset with the transport sector and things like that. So I'm first going to create a new data set called Thailand households and then click OK. So then the first thing it asks me is, would I like to look at the settings? And I'm going to click yes. And the first thing, the only thing that I'm going to change in the settings is that the data that you have for households goes from 2010 to 2019. So I'm going to say that the base year is 2010. The first year that I'm going to enter data for is 2010. But then I'm going to say the first scenario year is 2020. This means that it wants me to add in data from 2010 to 2019 for the current accounts for the historical period. And then we can create projections to 2030. We could go to 2040 or 2050 if we wanted to. So the first thing we want to do is, when we're looking at the households, we have here for Thailand and for the different regions the total number of households, but that's also linked to the population and the number of people per household. So when it comes to creating projections, we might have a projection of population but not have a projection of the number of households. So what's useful for us to do is to not enter this data of the number of households directly into Leap, but to calculate it from the population and the number of people per household. So what I'm going to first do under key assumptions is click add, create a category called population, and I'm going to add a key assumption that says that is the total population for Thailand, and the unit is people. Okay, so now I can enter in a population. So I'm going to enter in a population value. We've got the total population for 2000, 2010, 2015. If you have it available, I think it should be available for these years in between. We can add those. I'm going to enter this into Leap, and to enter the population into Leap, I'm going to enter the total population, which is this one here. So I'm just going to copy these two variables and then paste them into Leap. So now I've got the population in 2010, and then it sort of varies over to 2019. What I want to do now is excuse me, what I want to do now is break down the population into the percentage of the population that are in my different regions: Bangkok, Central, Northern, Northeastern and Southern. So I want to know what percentage of the total population is in each of these regions. I'm just going to quickly calculate that. This value divided by the total population times 100 to get it into a percentage. So now I've got my total population in each of these regions as a percentage. So I'm then going to add in to population more key assumptions. Bangkok population fraction. Let's call Bangkok population fraction percent. And I'm just going to copy that top branch, paste it into Leap as the percentage of the population that is in Bangkok. And I notice I've made a mistake here. In population, it's saying in year 2000 there was 60.9 people, which is a very small number of people for Thailand. So I'm going to change the scale here to million so that we get the actual population correct. So I've got my Bangkok population fraction. Now I want to know the average number of households in Bangkok. So the average household size. So I know this is the total number of households, and this is the number that I want to calculate in Leap. So let's take the year 2010 as an example. The average household size is the population, which is this number here, times 1 million, divided by the total number of households, times 1,000. Okay, that's not quite correct. So that's 1.85. Then we can calculate the same thing in 2015. So that is equal to the population. I got my number wrong. So this value here is the year 2000, so it should be C9. So I'm going to change that to C9. 2.4. So let's do the same for 2015. We have 8.6 million people divided by the total number of households in Bangkok. Okay, so it shows that between 2010 and 2015, the average number of people per household has decreased substantially. So what I think we need to check is whether that is true. So the population here has not gone up by very many in Bangkok between 2010 and 2015, but the number of households has gone up substantially. So we need to check all these numbers to make sure that they're consistent, but I just want to do this as an example. So if I go back to Leap, I've got my population fraction for Bangkok, and then I can add Bangkok people per household. And the unit is person per household. Okay? And then I can copy these values into Leap for the number of people per household. It would be great to be able to do this with population data for every year here. If that population data is available for 2010 up to 2019, ideally from the same source as the household data, because then we can make it all consistent and we can be calculating this in a consistent way. Okay, so we've got our key variables. Let's now actually start building the residential sector. So we can calculate these variables for the other regions in Thailand. In this video, I'm just going to do Bangkok just to show you how you can build the residential sector, but the process is the same for all the other regions. So in demand, to create our household sector, our residential sector, I'm going to right click on demand and click add. And then I'm going to click residential. This is my top branch. So I've got my residential sector, and I have two options here. I can change this to the total number of households, and I can enter in the total number of households that we have in the country at this top level. So I can enter that value there. Then I can add and create another branch for Bangkok. And then it will ask me to put in the percent share of households that are in Bangkok. So with this method, we first enter the total number of households, and then we enter the percentage share of households that are in Bangkok. That's a fine way of doing it and can be good. But I think the other way that we can do it is not to enter the total number of households, so to have no data at the residential level, but to then change the units for Bangkok to household. So we enter in the number of households in Bangkok directly, rather than entering in the total number of households in the whole of Thailand. And to enter the total number of households for Bangkok, what we do is not enter this number directly. So we could copy and paste these values. So one thing we could do is to copy these values and paste them here into Leap, multiply by 1,000 to give us the total number of households in Bangkok. That would be completely fine and completely correct. The other way to do it is to use the data that we've entered under key assumptions. So under key assumptions, we have two variables, the population and the number of people per household, that we can use to write an equation to estimate the number of households in Bangkok. So I can write an equation, and I'm referring to my variables by writing the path to get me to the variable. So I've got the total population for Thailand. In units of people. So I'm going to delete the million. The total population for Thailand multiplied by the Bangkok population fraction to get the population in Bangkok. So again, I'm going to write key population Bangkok population fraction, and I need to divide that by 100 because it's in percentage. So that gives me the population in Bangkok. To then get the number of households, I need to divide that by the average number of people per household in Bangkok. And this gives me about 3,700 households in Bangkok in 2010, which is approximately what we have here. It's not exactly the same because we haven't been we haven't had the data for every year in this data set, so it's not completely consistent. But if we had the data for the Bangkok population fraction and the Bangkok people per household in every year between 2010 and 2019, it would give us exactly the value that we would need. So the key is to have the population for the same years that we have the number of households to be able to use this method. And this then becomes very useful if we are going to create future scenarios. So we can then say how the population is going to increase, how many people are going to move to Bangkok, etc. And then the number of households will be calculated for us. We don't need to do that outside of LEAP, if that makes sense. So this really helps us when we're creating our projections. Okay, so that's how we create our folder, our branch for a particular region, and we can do the same for the other regions. The next thing we need to do is to specify the activities where energy or emissions occur in the residential sector. So I'm going to right click and click add, and then I'm going to include my first activity, cooking. So we have lots of data here about residential energy consumption. So this data that you've been able to collect for 2017 and 2018 is, I think, the most useful information in the data set that you have. So it gives you by region the percentage of households who are cooking using different types of fuels. So the first thing we need to do is add these fuels into LEAP. So we've got 5 fuels that are used for cooking: gas, electricity, wood, charcoal, and kerosene. And no cooking. We don't need to add in no cooking. So we want to add these fuels. Now for those fuels that have direct emissions, like LPG or wood, the way that we add them, we could just click add, technology with energy intensity, LPG, and then done. The problem with that is it doesn't have the emission factors underneath it, and it would take more time to add those emission factors. So what I suggest is that we right click on cooking and click insert branches from other area. This allows us to then import branches that already have the emission factors included within them. So I'm selecting the Thailand dataset, and I'm saying I don't want to import missing scenarios, missing fuels, missing user variables. I don't care about any of these things. I'm going to click import, and then I'm going to find in this dataset the branch that I'm interested in. So LPG I want to import. And you can see now that we have imported LPG, and we have all of the emission factors that we need to look at air pollutant emissions from LPG. I can do that again, select the same branch, and do the same for wood. I can do the same for I can do the same for charcoal. And I can do the same for kerosene. For electricity, I'm just going to click Add, and I'm just going to type in electricity. There are no emissions, so I don't have any emission factors to put in. Okay, so now that we've done that, we have two variables that we need to enter for cooking, or three variables. The first is that, so if we look at this brand structure, we have the number of households in Bangkok, and then it's asking us the percent share of households that do cooking. We actually want to change this to another type of percentage, percent saturation. Percent saturation just tells us what percentage of the total number of households in this case do something. It's not dividing things up between different activities. So it's not dividing up our cooking by type. It's just saying what percentage of households do cooking. So I've got 14 households here, 14% of households who have no cooking. So the percent saturation of cooking is 86% in Bangkok. So I'm going to actually put that in as INTERP 2017 86%, and then I guess the value in 2018 is 14.2%. So that is 85.8 in 2018. So I can enter that those values there of the percent saturation of households that do cooking. The next thing I need to say is what percentage of households cook using these particular types of fuels and technologies. So 75.8 and 76.7% of households use LPG. So again, I'm going to do 75.8, 2018, 76.7. And for electricity, it is 9.4 and 8.4. Okay, and then I've got the remainder here, 0.1, 0.6, 0.1 for firewood, charcoal and kerosene. So for one of these, let's pick wood. I'm not going to enter the values. I'm going to put remainder 100. And there's a slight mistake here as well that we need to be aware of. So these percentages here include the no cooking. So these values are not actually are not correct for what we want to do. They include the 14% no cooking. We want to calculate these values as just the percentage of households that use for the percentage of households that have some cooking, what percentage use LPG, what percentage use electricity. So ignoring the no cooking, what percentage of households use these different fuels. So I'm going to recalculate these percentages as the percentage without without the no cooking scenario. So the LPG is actually 88%. Electricity is actually 10.9%. Firewood still 0.1, 0.7. Okay, so let's just enter these numbers in here as an example. So for LPG, it was 88.1%. For electricity, it was 10.9%. I've put the remainder under wood. For charcoal, it was 0.7 and kerosene 0.1. Okay, so now I've entered all that data in terms of the percent share of households that use different types of fuels and technologies for cooking. The next thing that I need to do in order to be able to calculate my emissions is specify the final energy intensity, which is the number of gigajoules or the number of tons of oil equivalent or the number of megawatt hours of electricity or the number of tons of fuel or the number of liters of a particular fuel. I have lots of different units that I can specify this in, but what I need to know is for one household in Bangkok that uses LPG for cooking, on average, how much LPG do they use per year? That's the key variable that we then need to combine with our activity data so that we can calculate the total amount of fuel that is consumed. So I don't know that that data is readily available. We have data on the total electricity consumption, but it's not split into different types of fuels. We have here the electricity consumption, the LPG consumption for the total for the whole of Thailand, and that could be okay. So we could use that as we could use this value as a example, or we could use this value as an example. So this is the total amount of LPG that is consumed in the residential sector. So we can assume that that is all consumed for cooking, let's say. So let's take 2010 or 2017 as the example. 1749,000 tons of oil equivalent across the whole of Thailand is consumed for cooking. The value we want is how much does one household that uses LPG for cooking consume? Okay. So if I go to main cooking fuel, I'm now looking at the whole kingdom, and 63.9% of all households use LPG for cooking. 69.3% of all households. So I want to know how many households that is. So let me go back to my households. So 69.3%, 0.693, multiplied by this number gives me how many households that is. 3,583. 3,583 households consume LPG for cooking. I know that the total amount of LPG consumed in the residential sector is 1,648. So let me just do the calculation over here. This is not very not very good in terms of keeping everything neat, but I just want to show you the example. 1,648 divided by the total number of households. That number is, let me just correct the formula. So 0.0004599 thousand tons of oil equivalent. So if I times that by 1,000, that is tons of oil equivalent per household using LPG. So this could be the value that I use. The disadvantage of this value is that it's a value for the whole of Thailand. So I would need to apply the same value in Bangkok as the same value in the north of Thailand. That's okay as a first assumption. So I can put in 0.4599 tons of oil equivalent per household. I can do the same for wood, charcoal and kerosene. So for wood, in this value I don't have any kerosene consumption, but I can take the total amount of charcoal, divided it by the total number of households, that's LPG, wait a minute, I've made a mistake. So in the whole country, 7.5% of households are cooking using charcoal. So I need to recalculate this as 0.075 times the number of households. So it's much less. 7.5% is 387,000 households. So that value that I just calculated is wrong because I was using the wrong number of households. Then now you've got something that is more reasonable. 4.79 tons of oil equivalent per household using charcoal. And let's do the same for firewood. So 9.5% of households use firewood. So this is equal to 0.095 multiplied by total. And I've made a further mistake. I was multiplying it by the number of households in Bangkok, not by the number of households in Thailand. So I apologize. I've not fully woken up this morning. These values should be the total number of households in the whole of Thailand, not the total number of households just in Bangkok. So now my values are a bit different. So let me just calculate the value for wood. So it is the number of households using wood and I want to take this value here So it's equal to this value here divided by the total number of households. So I can enter these values here, 0.11 for LPG, for charcoal 1.15 or 1.16, and wood 1.10. 1.16, 1.10. I need to be careful to get the units correct. If I press Ctrl D, it says shortcut and it copies what is above, so I can easily change those units. Now for electricity, which is the other main fuel used for cooking, it's not so easy. I don't have the amount of electricity that is used for just cooking. I just have the total amount of electricity that is used in households, which covers cooking and lighting and air conditioning and other variables. So I just have the total amount of electricity used, which is great that we have that. My question about additional data that would be needed is whether there is any information about how this total residential electricity consumption breaks down in terms of use. So is there any information about how much electricity is used for cooking? How many kilowatt hours per household of electricity is used for cooking compared to air conditioning, compared to lighting? So once we finish cooking, we can add other activities. So we could add lighting. And then we need to know the percentage of households that have lighting. So we assume 100%. And then we would want to add our fuel, which would be electricity. And for that, we would then need to know the average amount of energy, average amount of electricity consumed per household for lighting. We could add other activities like air conditioning. And again, electricity is the fuel that we're interested in here. But to be able to do this detailed bottom-up approach, we would need to have some information on the average electricity consumption for these other applications. If we don't have that information, then we could delete air conditioning, delete lighting, and just add in a branch called other. And then include electricity here. And then the other would be the electricity consumption without cooking. So the key data to be able to apply this approach is, on average, how much electricity is consumed for cooking. If you have that information for Thailand, then that would be incredibly useful. If that's not available, I can look and see if there are if there's data available for that for Southeast Asia or for in other international studies. But I think it's useful to see if we can get that information for Thailand. Once we have that, we can decide then whether we group all the other appliances and applications together in an other category and just have the electricity consumption there, or whether we are able to split it from different types. Because there's no direct emissions, it might be easier and make sense just to do other electricity consumption, and then that feeds into our power generation module. but that's something that it would be useful to discuss. So I don't think I have anything else to say. I will send you this data set. Please let me know if you have any questions, and I look forward to talking to you soon.